Good morning. In this video, I'm going to discuss sterilization, specifically the calculation of thermal death point and thermal death time. So let me share the PowerPoint. Okay. So the most common way of sterilizing biochemical system is the use of steam, or in other words, it's also known as moist heat. um, for equipments, specifically the inside of equipments. Generally, equipments are made up of stainless steel. Um, it's common to see that the plants are using steam, kasi it's quite common to produce steam. Most of the plants have boilers, and it's very convenient to use. On the floors and on the walls, generally they use sodium hypochlorite solution, or your Clorox, no? Um, if it so happens that the number of microorganism is beyond the control of the of sodium hypochlorite, they could use a more powerful substances like quaternary compounds. Siyempre, the disadvantage is more expensive to bring forth sterilization in the area, especially in the surface of the equipment, on the floors, on the walls. It's quite common here in the Philippines because most of our facility are involved in food production. Mm, So this particular slide discuss how steam kills microorganism. So basically the mechanism of killing is a combination of protein, nucleic acid denaturation. So microorganisms are made up of protein and nucleic acid. So because of the high temperature of steam, when the two is in contact, the protein, the nucleic acid, and the steam. So generally, the protein and the nucleic acid will be denaturized or destroyed. Effectiveness heavily dependent on type of cells present as well as environmental condition. So type of medium or substrate. So basically, there are bacteria that are relatively not affected by steam, especially those spore forming bacteria. They can survive steam for a reasonable length of time under exposure to steam. So all you need to do with this type of problem is just to increase the amount of time that you're going to the length of time that you're going to expose, the system on steam. So bacterial spores are much more difficult to kill than vegetative cells. It's because bacterial spores uh, are protected, by a by a more stronger layer, more resistant to steam. So that's why they are much more difficult to kill than vegetative cells. So for example, in canning industry, in canning industry, uh, there's a possibility that some bacterial spores are present. They are common in canning facilities. So instead of using the usual 5 minutes of exposure to steam, okay, they generally use 15 minutes in order to make sure that these bacteria are killed or destroyed. No? Okay, so let's go to some technical aspect. First is the sterility level or the destruction ratio. So this is equals to N over N sub O. N is the number of microorganisms still alive present in the media after sterilization. While N sub O is the initial number of microorganisms. So generally, syempre, N sub O is much greater than N. N is the number of bacteria after sterilization. Syempre, the sterilization will kill the bacteria and reduce the number of bacteria to N. Okay, so the rule of thumb for sterilization level in fermentation industry is 10 to the negative 4. Okay? Ibig sabihin, halimbawa, you have 10,000, initially you have 10,000 bacteria. So, it is required in the fermentation industry that only one bacteria will remain after sterilization. So, that's N over N sub O is equals to 10 to the negative 4. That's the rule of thumb. Ano? So, by probability, you need to expect 1 in 10,000 tanks will be contaminated. Kasi hindi rin pwedeng magtagal masyado sa fermentation industry na iinitin mo. Ano? Ang disadvantage kasi niyan pag masyadong mo ring in-sterilize ng masyadong matagal, baka yung ibang components ng media ma-denature din naman. Ano? Baka wala nang makain yung microorganism nyo na gagamitin. Wala na kayong ma-produce na product. In short. So, sabi ko nga sa inyo, sa canning naman, medyo mas mataas yung requirement. So, sa canning, ang sterilization level ay nasa 10 to the negative 12. No? So, what's that? 10 to the 12 zeros. Ano? Billions is 9. So, that's trillion. Ano? So, parang, halimbawa, you have 1 trillion bacteria. Isa na lang yung matitira pag 10 to the negative 12. So, we're very careful in planning kasi nga merong common sa canning industry yung Clostridium botulinum. So, ito yung nagko-cause ng food poisoning, you know? So, we want to eradicate the Clostridium botulinum. Tapos ang problema sa Clostridium botulinum, it's spore forming. So, na-mention ko na naman kanina na pag spore forming, nagsusurvive siya sa heat, no? Ng mas matagal. So, that's why you will need, basically relatively longer sterilization time in the canning industry. Okay, so we have here two measurements of killing by moist heat. The first one is the concept of thermal death point. So thermal death point, kasi it's a temperature, no? It's a temperature. This is the lowest temperature at which a microbial suspension is killed in 10 minutes. So specified yung time, tapos yung i-calculate nyo yung temperature. So this is the lowest temperature at which microbial suspension is reduced to its sanitation level. So in calculating this concept, mamaya, basically we're going to use the two equation that we have already used in our previous topic. So probably we'll be using the first order equation. Ano? So, di ba tandaan niyo pa yung first order equation, yung N is equals to N sub O E to the negative K and then times time. Ano? Yan, gagamitin natin yan. Tapos itong tida dito sa TDP, fix yan sa 10 minutes. Yung K, usually given yan sa problem, yung usually what we have is the N over N sub O. Katulad kanina din-discuss natin, di ba? Di ba yung N over N sub O, pwede siyang 10 to the negative 4 sa fermentation o kaya naman ay 10 to the negative 12 sa canning. So, ang mangyayari dito kung meron kayong time, tapos given naman yung N over N sub O, you'll be able to calculate the K. no? Yung K, remember that's the parang reaction constant, ano? Yan yung thermal death rate, ano? Itong K na to. So, how do you find the temperature? So, in order for you to find the temperature, gagamitin natin yung Arrhenius equation. Just like our previous calculation. So, if you still remember the Arrhenius equation, pag alam niyo na yung K value, di ba, this is equal to yung K sub O times E to the negative activation energy E sub A divided by RT. So, yun. Just use your calculator to solve uh, the thermal death point. Itong T na to, ito yung magiging thermal death point. Okay? Kasi yung time is fixed dito. Pag thermal death point, fixed siya sa 10 minutes. So, ang hinahanap dito yung temperature. Pag thermal death time naman, TDT, this is the shortest time needed to kill all organism or basically to achieve the objective of sterilization at specified temperature. So meron kayong given na temperature dito sa thermal death time, may specified yung temperature. So you're going to use this equation. Usually, alam naman yung yan, E sub A tsaka K sub O. Tapos malalaman niyo yung K. Tapos pag nalaman niyo yung K, punta kayo dito, alam yung N over N sub O, makakalculate yung T, yung time. Ganun lamang yung thermal death time. It's the shortest time needed to kill all the organism in a suspension at specified temperature under a specific condition. Okay? So let's try to do some calculation of thermal death point and thermal death time. So start muna tayo sa thermal death point. Suppose in a canning operation, the sanitation level is 10 to the negative 12. You need to estimate the lowest temperature, this is your TDP, at which the said sanitation level can be obtained in 10 minutes. If the standard death rate constant, K sub O of Clostridium botulinum, is 16.6 times 10 to the 37 per minute, and the activation energy to be 68.7 kilocalorie per mole. So, let's start with the first order equation. So we have N is equals to N sub O E to the negative K times time. So, rearrange nyo lang to, magkakaroon kayo ng N over N sub O. Tapos N over N sub O is equivalent to 10 to the minus 12, no? So, 10 to the minus 12. Tapos E. Pag ang hinahanap ay thermal death point, palaging ano yan, 10 minutes yung time. So, meron tayong value ng T, no? So, negative K, tapos 10 minutes. So, with this, you can use your calculator to shift solve the value of K. So, the death rate constant is 2.763. Ganun na. So, this is per minute. Tapos, we're going to use the Arrhenius equation to calculate the temperature, the thermal death point. So, the Arrhenius equation is K is equals to K sub O E to the negative EA. This is activation energy. Tapos gas constant R. Tapos T. So, yung K natin is 2.763 per minute. Yung K sub O natin, ito, 16.6 times 10 to the 37. Okay, per minute din to. So, magka-cancel out lang yung unit. E, ang activation energy natin is 68.7 kilocalorie. Kasi yung gagamitin nating R would be 8.314. Ito ang unit nito ng 8.314. Tandaan nyo naman siguro, joules per mole per Kelvin. So dapat itong 68.7 na ito, i-convert natin sa sa joules. So to convert 68.7 kilocalorie to joules, di ba, that's also equivalent to 68,700 calorie. Tapos i-multiply nyo lang basically ito ng 4.184. That's joules per di ba? This is joules per calorie. Tapos, yun, you can now, by using ship salt function, you can now calculate the temperature. So, yung lalabas sa temperature dito is in Kelvin. So, if you're going to use your calculator, you're supposed to get something like 397.42 Kelvin. This is equivalent to around 124, 124.27 degrees Celsius. So malapit lamang 'yan dun sa, 'di ba, dun sa rule of thumb natin, natatandaan niyo yung first lecture natin. 'Di ba ang rule of thumb ng sterilization ay 15 minutes, 121 degrees Celsius. So yan, malapit naman siya. No? Okay? So next, let's calculate thermal death time. You need to estimate the time needed to have a sanitation level of 10 to the minus 12 at 121 degrees Celsius. So ito naman, pinix naman natin yung temperature, 121 degrees Celsius. Yun pa rin yung ating sanitation level. Yun yung standard sa kanin, 10 to the negative 12. So we have the same K sub O value, 16.6 times 10 to the 37 per minute. Tapos we have the same activation energy, 68.7 kilocalorie per mole. So ang hinahanap natin dito yung time, TDT, thermal death time. So this time, magsisimula naman tayo dun sa Arrhenius equation natin. Ano? So ang Arrhenius equation natin ay K is equals to K sub O. Calculate muna natin yung K using the Arrhenius equation. E to the negative E sub A over RT. So, let's substitute the values. K sub O, 16.6 times 10 to the 37 per minute. Tapos times E, negative E sub A is 68,700. Ano? Kasi kilo times 1,000. Tapos, para maging, this is calorie, This is calorie. So, para maging joules, multiply lang natin ng 4.184. So, this is joules per calorie. So, kaya natin ginagawa itong conversion na to, kasi yung R na, usual R na ginagamit dito is 8.314. Ito yung isa pang R na dapat memorize nyo aside from 0.082. So, this is joules per mole per Kelvin. Tapos, multiply nyo ito ng temperature. Ang temperature natin, 121. So, don't forget to convert this to absolute. Kailangan absolute kasi dito sa R, K siya. No? Okay. So, just try to solve for K. You're supposed to get something like 1.34. So, this is per minute. And then, after this, you just use the first order equation N is equals to N sub O E to the negative K T. So, yun. Itong T na to is the time. Small letter T. Is the time. So, that will correspond to the thermal death time. So, ang N over N sub O natin 10 to the minus 12 pa rin. E, ang ating K ay negative 1.34 per minute. Tapos, you can now calculate the time. So, using your calculator, tapos shift solve, you're supposed to get something like 20.62 minutes. So, this time, this is your TDT, thermal death time. Okay? So, I hope you get this one. And, syempre, sa exam, be careful, as long as alam nyo kung ano yung gagawin nyo. So, kasi single attempt lang, be careful with your calculator. Okay, so see you on the next video.